Hi class, so today's lesson we're going to be multiplying. We're going to start by multiplying a polynomial, so has more than one term, poly, by a monomial, meaning it has only one term. So we're going to be using two things that you are quite familiar with. We're going to be using distributive property. Everybody knows and loves distributive property. So we're going to use distributive property, and if you don't know it and love it, you got another chance to learn it. So distributive property, and we're going to be using the product rule, right? So product rule we just learned. Well, so you might have known it before, but keep in mind your exponent rules. So notice what it says at the bottom, while distributing, keep in mind your exponent rules. So those are the two things that we're going to need to keep in our minds as we do this. So we're taking that 8m squared and we're multiplying it times every term inside the parentheses. So we're doing 8m squared times 2m squared. So 8 times 2, coefficients multiply, exponents add. And this should be the very next page in your notes. It is labeled as page 30 at the bottom of the page. And then 8m squared times 6m. So 8 times 6. Multiply those coefficients, add my exponents. Remember this guy without an exponent, it's understood it's a 1, so 2 plus 1 makes this m to the third. And then last part, 8m squared times the negative 7 is negative 56m squared. So, more than one way to think about that distribution. Some people call this rainbows. Rainbow it out, right? Because it kind of looks like a rainbow when I drew that. Other people like to do it more like a long multiplication problem. So they might write this down. I don't like to do any extra writing if I don't have to, and then they take the 8m squared, and they might even go right to left like long multiplication. So 8m squared times negative 7 is negative 56m squared. 8m squared times this positive 6m, 48m to the third. And then 8m squared times 2m squared is 16m to the fourth. And we need those signs in between terms. You get the same answer either way. I just typically go left to right and move across that problem. Now there are some times when problems get more difficult and longer that I use somewhat a method that looks more like long multiplication. But please know, if you feel more comfortable doing it in another way, you should still be getting the same answer. But that 8m squared is going to get multiplied by every term. And as we look through some of the more difficult problems, I'm going to model them in more than one way. And you can choose then which way you prefer. It does not mean that you need to do it 5 different ways. Just means find what works for you. So this question, very similar. So you might pause the video, work it out yourself, and then unpause and see if you and I got the same thing. All right, so if you're back, hopefully our answers agree. We're multiplying the coefficients, adding the exponents. If one of them doesn't have a variable, then the exponent that's on the outside would just still stay the same. There are no like terms to combine because they're all different exponents. So if it was still multiplication, we would be adding those together. But at this point now, it's addition and subtraction. So we're done. Notice there were 3 different terms inside the polynomial in the parentheses, and there are 3 terms in your answer. Right, since we're only multiplying, and they went down like from second power, first power, no b, so they're going down by 1 power each time also in the answer. Now, sometimes instead of that, you're going to have a polynomial times another polynomial. And in fact, in this case, we're going to start out just doing a binomial times a binomial. So they each have 2 parts. That's why we call that they're special polynomials with 2 parts we call binomials. So what this really means, this means the same thing as if I wrote x times the x plus 3 and negative 5 times the x plus 3. Now, I would not suggest that you have to rewrite that, but I'm just letting you know that that's what it means. It means you're going to take the first thing in the first set of parentheses and it gets to multiply times both terms in the other set of parentheses. Then the second thing in the first set gets to multiply times the other 2. They never multiply within the same set of parentheses. They're multiplying times the term in the other set. So let's see what that looks like. And typically I just think of this as going from left to right. So starting at the left with the x, this x times this x gives me x squared, right? Because they both would have a 1. Next, I'm going to do this x times this 3. So 3x times 3. Now we don't usually write x3, we would write 3x. And it is positive, so I'll put plus. That x is done multiplying now. He's multiplied with both terms in the other set of parentheses. Now I'm ready to go on to my negative 5. And I do want to think of that sign being attached to the 5. Now negative 5 times x is negative 5x. And then negative 5 times 3 is negative 15. So the colors were purposeful here so you could see which arrows went with which parts of the product. So there were 4 parts of multiplying. So now I have 4 terms, and then the last step is that we combine any like terms. And in this case, those like terms are living right there in the middle. So this is x squared, 3x minus 5x is negative 2x, and then negative 15. So that would be my final answer. So since they are binomials, sometimes you in traditional school might have heard that called FOIL. And the reason that sometimes people refer to that as FOIL is an acronym, and it's first times first, and then it's outside, outside, that's the O, and then the I is inside, inside, and then the L is last times last. Now, I don't use the word FOIL very often because it really only works if it's just a 2 by 2, if both of them have only 2 parts. Because if one of them has 3 parts, well, then what, right? So it only works in limited situations, which is why I don't typically call that FOIL. I just think of it as distributing. But notice if I go in the same order that I went with distributing, I am doing the first times the first, the x times the x, that's the first in each set of parentheses, the outside terms, x times 3, the inside terms, negative 5 times x, and the last terms, negative 5 times 3. So just another way to think of it. Sometimes I might say something to you about like, hey, you forgot your outside, and inside. You forgot your outsides and insides. Like if you gave me this answer and only said x squared minus 15. Like that would mean you forgot those middle steps. All right. If you are very visual, you might like the rectangle method, also known as the box. And so I probably more often call it the box. So if you hear me talk about like you might try the box, you might, this is what I'm talking about. So this is the same problem, just going to show you just another way to do it. So if I would take this first binomial and put x minus 5. By the way, it doesn't matter which one goes along the side and which one goes across the top. And x, in this case, this would be plus 3. Now, I look, x times x, so if I'm in this box, I'm doing this times this. Kind of like reading a multiplication chart, right? So x times x, that's x squared. And it doesn't matter which order you do these in, as long as you put them in the right boxes. So I can do x times negative 5, or I could have done 3 times x next, or x times 3. And then in the bottom corner, that's where negative 5 times 3, right? That's kind of like finding an ordered pair or something. So in that case, that's where that would go. So 3 times negative 5 is negative 15. And then these two guys on the diagonal, they can be combined. They're like terms. If some of you, maybe in school, or maybe your children in school, have done something called the lattice method for multiplication or addition, if they've used lattice, this might remind you of lattice and how you add up things on the diagonals. If that doesn't mean anything to you, that's perfectly okay. It's kind of a less traditional method. So again, sometimes this helps people because if one of the boxes aren't filled in, then they know they missed a step. So those were binomials times binomials. And we have a little bit of practice here. And again, we could use any of the 3 methods. They should all turn out to be the same answer. So thinking about what I've shown you, you might think for yourself, which one do I think I prefer? And try this problem, put me on pause, try this problem, and see if you end up with the same answer. If you chose to do this with distributing, or you chose to do it with FOIL, your work is going to look the same. So whether I'm saying first times first, or I'm just thinking, maybe writing those little marks, but for sure thinking this times this, and then this times this, the order of my partial products would be the same. And then at the end, I still would need to combine my like terms. And if you prefer, you could write 1m in the middle. Instead of writing plus m, you could put plus 1m in the middle. That would also be the same thing. Okay, so hopefully, if you did it on your own, you got the same answer. I'll show another example with a rectangle in just a moment when we have a longer problem, because that's where typically people get into more trouble about leaving part of it out. Well, I could show you. I will do a rectangle this time. If you like just distributing or thinking of it as FOIL, you should get the same answer as I'm going to get with my rectangle or my box. So I'm going to write, this is 4x, so each term along the side there, and this one x plus 3. I could put it either way. And then you're going to fill in the boxes. So if you want it, you could do -2 times 3 first. Doesn't matter. Doesn't matter which order you do them in, as long as you're taking the correct two terms to fill in that box. 4x times x, 4x squared, 12x, -2x. And then at the end, just like the other way, these are the same 4 terms that you should have if you did one of the other methods. Combine the like terms, because we want our final answer in simplest form. So 12 and -2 would make that plus 10, and then minus 6. Pardon me if this is on here twice, but I had paused the video and I'm not sure if I got this part recorded. So I'm going to record it again just to be safe. So 2x plus 4 squared, the quantity squared. So it may not seem important, but it is important to rewrite this. And if this is the second time that I have this on this video, just fast forward a couple minutes. So I'm going to rewrite that, and then I just do the same process I've been doing. So 2x times 2x, 2x times 4, 4 times 2x, 4 times 4. Combine my like terms in the middle. So it's important to expand that and rewrite it as 2, or to just mark off the squared and rewrite it again next to that. That kind of works, right? Because then it's there twice. Because when people don't rewrite it, they typically forget about these two parts. They give me an answer of just 4x squared plus 16. And because of the plus in the middle, that's not the same thing. So it's not true. All right, so now we have seen multiple problems with binomials times binomials. This was still a 2 times 2, 2 parts in each one. We're going to look at multiplying with trinomials, which we did some of that at the beginning, but it was only with a monomial times, right? So we can use distribution, we could use the box, the rectangle. So I'm still going to use distribution, but I'm going to arrange my answers in 2 rows, and then that's going to help me organize my like terms instead of one great big long row. If you do one great big long row, it's okay, but then you got to go hunt for your like terms, because they're not going to just end up next to each other anymore. So here we go. I'm going to start going left to right. So starting with that 6x, remember he doesn't multiply with something in his own parentheses, he multiplies with things in the other parenthesis. So I'm going to go here. So 6x times 6x squared, 36 6x to the third, right? Because that x is as if it has a 1. Now 6x times 7x. And you might draw those lines or arrows, or that's just kind of thinking. I'm just trying to show you where I'm going with things. And then 6x times just regular 7 would just be 42x. So the 6x is done multiplying. Just like if we were multiplying a 3-digit number times a 2-digit number, we would have one row, and then when we went to the other digit, we would have a second row. Same kind of thing is going to happen here. So now I'm going to start with the 1. So now the 1 is going to get his turn to be the guy multiplying. And since my other stuff's down there, I'm going to start with 1 times 6x squared, which would be 6x squared, of course. So I'm going to scoot that over so that it's written under the other x squareds. I'm not going to line it up under the 36x cubed. I'm going to put it under the 6x squared under the 42x squared. Then 1 times 7x is 7x. Once you scoot it over once, things are typically from then on going to be in the right order, because unless your polynomials skipped an exponent. And then 1 times 7 is, of course, 7. Now, I still have to combine like terms, but my like terms are in columns. So then 36x cubed plus 48x squared plus 49x plus 7. So 36x cubed plus 48x squared plus 49x plus 7. So if you liked the box, what that would look like with the box, and if you didn't like the box, you can fast forward here a little bit. If you like the box, and you think that would help you make sure that you remembered to do all the parts, well, now that I have a 2 by 3, I'm going to have 6x plus 1 here, but I need 3 parts this way. And you can see why this is more of a rectangle, right? I just heard one of our students' son yesterday say that he did arrays. And so these rectangles for multiplication might kind of remind you of an array for multiplication. So 6x squared, 7x, and 7, and these are positive. And then again, it doesn't matter what order. I still kind of start with the top left personally, but you could start anywhere as long as you follow to get the right ones in the box. So 6x times 6x squared is what's going to go in this first box. So there's 36x cubed. 6x squared times 1 would be down here. 6x times 7x. 1 times 7x. 6x times 7. And 1 times 7. And then remember that it's the parts that are on the diagonals that are going to combine. So that 36x cubed stays what it is. Then we'd have 48x squared. Then we'd have 49x. And you should see that our answer is the same. So, different people have different opinions. Some people love the box because it helps them make sure they don't forget any parts. Other people say, Miss Carolyn, if you make me do the box, I'm going to hurt myself. Hopefully not seriously. But, I mean, it just feels like extra work because you have to rewrite the problem. but if it helps you so you don't forget any of the parts, it's worth rewriting the problem. But both ways, final answer should be the same. Absolutely the same. We will actually look at that lesson a little later. So that is the multiplying lesson, and I will have something posted that you can do. You'll have a choice. It'll be another choice day. I don't know, maybe you guys would rather not have choices, but you'll have a choice of a multiplication set of problems that will be like on the teacher made thing, and I will show you in the other video how to type the exponents on that program, because there is a way to actually type exponents. Or you can do Z6. So that's like the beginning problems, right? So this would be 2g to the 4th minus 3g squared. So lots of exponents in here. So that is what Z6, you're just 1 on the outside. Z7 is also multiplication. Oh, I missed it, sorry. So Z7, in Z7, Z7 is algebra tiles multiplication, and we're not actually going to do Z7. Z8. So here we go. Here is Z8, and you start seeing things where you're going to have to distribute and have some combining like terms to do. These are all going to be binomials. So FOIL, using that acronym, would work. Distributing would work, or the box would work. 4t times 3t, that's my first times first. 12t squared. Last times last, so I already did this one. 4t, then inside times inside, negative 3t, and last times last, negative 1. Combine those like terms in the middle. Okay, so Z, that is basically what's happening in Z8. They are all going to stay binomials. You could get things that have higher exponents. Just follow your exponent rules. Again, it will be your choice whether to do the what is traditionally a paper assignment, or to do this on IXL. And then down here where it says multiply polynomials in Z10, and now you see the ones where you have 2 on the outside and 3, so we have a binomial times a trinomial. So I'm going to start with this times this. They got those some negatives in here, so they're trying to be a little tricky on us. So negative 4d to the 3rd. Then I'm here to here, negative 6d to the 2nd, and negative 8d. Now I'm going to go to the 4. It's his turn. 4 times negative 2d squared would be negative 8d squared. So remember, we're going to scoot it over so that it's underneath the like term. If you prefer to make it all in one big line and go find them, you are certainly welcome to. Minus 12d, and 4 times negative 4, minus 16. And then we're going to combine those like terms, and that's what we'll be entering in our answer. So I would not advise that you just try to do this in your head. I would advise that you write things down on paper. So negative 4d cubed minus 14d squared minus 20d minus 16. Notice that the exponents do not change on the combine like terms step. Exponents change when we're multiplying. Exponents change when we divide. Exponents do not change when we're adding or subtracting, which is what we're doing at the end when we combine like terms. All right, so looks like maybe there is a little more on multiplication, but I think we're just going to go with those three because that special products is something that I will show you in as a part of another lesson. All right, so 3 IXL, 6, 7, and 10, 6, 7, and 10, or the worksheet as far as multiplying.